I've gone ahead and entered the weights of the dogs in list 1 and the cats in list 2. So if you guys can tell here, we're not given the true standard deviation. It's not been given to us. And we definitely have 2 groups. We're talking about means. It's not proportions like the last 2 problems. So that if you look at your pink sheet, that only leaves us with 2 sample t-interval. And I'm just going to go right there on my calculator. So I already have the data entered in my calculator. So stat test and number 0. And I'm going to tell it data, and I'm going to say, hey, use my list 1 and list 2. Leave your frequencies 1. Okay, this time we're asked to do 90%. Pull no and calculate. Okay. Since these numbers are so far apart, I'm just going to round these to whole numbers. So 12 and 37. And remember, our unit is pounds. So to describe this in context, this is kind of nice because they're both positive. So when we start a sentence, we're going to start with dogs because that's what we put in first. And we're going to talk about the true mean. So we are 90% confident the true mean weight of dogs is, and these are both positive, so I'm going to say 12 to 37 pounds more, can't see that, there you go, than true mean of cats. Okay, question number 10. Here is the times of the first day of 7th grade track practice in minutes, how long it took this group of kids, each person, to run 2 miles in minutes. So we're going to calculate this by hand, but it's okay to use your calculator. So I've entered into list 3 this data, and I'm going to get these numbers from my calculator. So that we've already learned in the past. So stat calculate one variable stats, and I want it to do that for list 3 for me. Okay, so there's my sample mean. I'm just going to call that 18.4. The standard deviation, we want to look at the S because this is not all 7th graders in track in the whole world. This is just a sample. So S, 3.9. And then we have 8 kids represented here. So since we're using the from a sample, this is not a true standard deviation. That's called a t-interval. And you can look at the formula on your pink sheet. It is, I believe, x bar plus or minus t star times s divided by square root of n. Okay, so we'll talk this through here in a second. So we have 18.4 plus or minus t star, we'll look that up, 3.9 divided by square root of 8. So I'm going to go to Google because I don't have the yellow sheet for t star, but one thing you need to know is degrees of freedom is always n minus 1. So you would look on your yellow sheet, where does 7 match up with 99% confidence interval, and that is your t star. So I'm going to pause and look it up, and then all right, so I found it online. 3.499 is our t star value. So I've entered that part in my calculator. So that means we have 18.4 plus or minus 4.8, making my confidence interval to 23.2 in minutes. And I'm not going to make you write a sentence, but that would be the true mean. We would expect it would take kids between 13.6 and 23.2 minutes to run 2 miles. Number 11, a survey of 12 freshmen found only 2 of them plan on going to the district basketball game. Calculate a 95% confidence interval by hand to estimate the true proportion of all freshmen who want to attend. All right, the reason we're going to do this is because I think we're going to get a strange answer. So we only surveyed 12 freshmen. 2 of them said they are going to the basketball game. So that's 0.167. I'll round it to. Okay, by hand. So remember, so minus P. No, I'm forgetting. I don't have that pink paper in front of me. Okay, P hat plus or minus Z star. What's this, right? All right, so I entered everything in. You can check that math. But here's where we're going to get a strange answer. So when I take 0.167 and subtract 0.211, I get a negative answer. And a positive answer. So we're talking about one proportion right now. We're trying to figure out the true percentage of all freshmen who are going to go to the game. So I know we had a negative and a positive before, and that was fine. But if you only have one proportion, you can't have a negative percent of freshmen there. So if that happens, you just start with 0% to 37.8%. The same goes as you can't go over 100%. Okay, so remember that for your test, because that just might happen. Also, for a bonus question, I'll show you my coffee mug I'm drinking out of. Can you guys read that without me tipping it? Here's the one that goes with it. So there's Mr. Right, and then mine's Mrs. Always Right. I love it. It's my favorite mug. Okay, so let's write this sentence. Hi, Nessa. We're 95% confident the true, I'm going to use percent this time, of freshmen going to the game is between 0% and 37.8%. Remember, you can't have a negative percent for that answer. And finally, how many clams do you have to sample in order to estimate the average length? 95% confident. E squared. Okay, so 1.96, 3.8, and squared. 5 clams. Hope that helps. Happy studying.